So, looking at exercise 3B, question 8. Now, it's this one here. A little bit tricky to think about, but I'm sure some of you want to be able to do every single question in the book. Now, the other problem with this exercise is that the solution at the back of the book is a little bit wrong. Anyway, let's look at the question. It says f of x is x plus k divided by x squared plus k, and it's never increasing. What does that mean? It means the function's never going uphill, never has a positive gradient. Hence, if I find the derivative, which would give me the gradient function, I would need to make k some number so that that derivative was always negative. And that's really all there is to it. Derivative. So what we've got here is something that you would find the derivative using the quotient rule most likely, or the product rule, but probably the quotient rule because we have a quotient. Some function divides some other function. So like I've been doing in class, I like to make a little list with my u's and v's and u primes and v primes so that I can then find the derivative. And this part, I think a lot of you would have been fine with. Right, so remember we're connecting that oov and that oov. Quotient rule needs a minus. What do we get there? X plus k. Quotient rule is different to the product rule in that you will have a v squared on the bottom. X squared plus k. Now because of that squared, by the way, that will always be a positive number. What we're trying to do is make this derivative be negatives always by changing what k would have to be. And I'll just tidy up the top. What have we got there? An x squared minus a 2x squared will be minus x squared. Then we've got a k here. Here we've got a 2xk, so we've got minus 2kx if I expand there. And we've also got this k. I can't be bothered, right? I'm just going to write v squared here because it's quicker. And let's do a little bit of extra factorizing. That'll be a plus now. And the k will be a minus on v squared. I need this derivative to be smaller than 0. All right, when what? Right, now no matter what the x is or what the k is, whatever the numbers are, you're going to square the bottom's always positive, right? I'm basically forgetting about the denominator altogether. What I need is for this bit in here that I've put in brackets to be a positive number. Then it will be multiplied by this negative, and this will always result in a negative derivative. Right, so what I need is x squared plus 2kx minus k to be greater than 0. All right, now what I want you to recall is, well, at least this is how I think about it, is graphing. And this, what I'm left with here is a quadratic. And I'm thinking about, when do I get quadratics that are greater than 0? I think of a graph, right? I think of a quadratic, maybe a nice simple one. There's my y, there's my x. Maybe this is y equals, well, it's on the axis, x squared plus 3 or something. You know? There are no roots, right? It never crosses the x-axis. when I do quadratic formula, you will get no solutions. And why is that? Let's just quickly write out quadratic formula. What is it? B squared minus 4ac. How do we get no solutions when we have, well, it's because of this surd, isn't it? If that's negative, we're in trouble, right? If it's negative, you're up here and you have non-real roots. If I put this example into quadratic formula, I will get a negative discriminant. Remember, this is done at the start of year 11, I believe. So when's the discriminant? We're looking for this negative discriminant, all right, as in that bit in the surd there. So, for example, if I put this in, well, I might need to stop and think, what's the b term here? It's a 0, right? 0x plus 3. So my discriminant would look like 0 squared, which is pretty easy, minus 4ac, minus 4 times 1 times 3. So I get minus 12. Right? Can't do it, but obviously it's still a quadratic. It just never crosses the x-axis, and the y values, right, are always positive numbers. Right? So that's what I'm looking for here. I need whatever I put in, whatever k is, whatever x is, I need to be getting a quadratic like that, where it's always positive. So I really just need to think about the discriminant of this quadratic. We can write out the whole thing in quadratic formula if you like. So if I take it up here maybe, we'd be saying that x equals minus b, that'd be minus 2k. Whole thing's on 2a, should just be 2, plus or minus the square root of b squared. Well, the b is a 2k, so 2k squared is 4k squared. Then you have a minus 4ac. The 4ac, 4 times 1 times minus 1 would be a minus 4. And we've got minus 4ac, so we've got minus minus. We've got plus 4k. You might want to be doing this for yourself. I don't really care about the whole formula though. I just need to focus on the discriminant. So I need to know when, or consider when 4k squared plus 4k could be smaller than 0. It's a situation, I mean, you could divide everything by 4. When could something squared be smaller than minus of that something? And hopefully you can see there wouldn't be very many cases, because normally if I square a number, it's going to be bigger than the number. Just forgetting about the minus for a minute, which throws another spanner into the works, but I don't know, like the number 2, if I square 2, it's 4. It's squares are always bigger than the numbers you start with, aren't they? Aren't they? Unless you had something like a half squared. What happens to a half squared? It actually goes smaller when you have fractions times fractions. What's a half of a half? That's a half times half. That's a quarter. Right? So it's in this region here between 0 and 1. Now, let's consider the negative. Well, let's actually go back to that and think, if I was to factorize it, I think I will divide by 0 though. I'm gonna say this: k plus 1, I need it to be smaller than 0. And I've got to think, when would this thing here give me negative numbers? what I could do is a sign diagram of this equation, which is really the discriminant. I could say the discriminant equals. So we can do sign diagrams of anything, of derivatives, second derivatives, functions. What the sign diagram tells us is when is this equation or function, when is the function positive or negative, right? Normally I'm doing sign diagrams of derivatives and I'm trying to see when is the gradient positive or negative, and then I can make the statement about when is the function increasing or decreasing. But we can do it here as well. So we could say this equation that I've got here, it will equal 0 if that k is 0, or if that k there is a -1. This is just null factor law, right? Okay, if I went for really small numbers, -2, it's not that small. Okay, if I go into this region here on my sign diagram, I'm doing this of the discriminant as my label, and I made k -2. I'd have -2 times -1. I'd have negative times negative. It's only in this region here that I would get negative values. For example, -1/2. All right, I'd have -1/2 times +1/2 coming from the k plus 1. That would give me -1/4. Right, as soon as I go above 0, like 1's above 0, I've got 1 times 2. It's positive again. It's only here, right? And that's the answer. K needs to lie between 0 and -1. -1 and 0. There's your answer. Now the book, let me just, how am I going to blank everything? Oh, I press that button, clear all right. Let's have a look, because I think they've made a mistake in the answers. Did I have the answers up before? No. All right, bear with me. I'm going to go to the answers. I'm pretty sure that they said between -1 and +1, and that's wrong. And I went to Desmos and I checked it, which I'm about to do with you guys. But first we'll just find it. Where am I? That's 3D. No, we're in 3B. It's probably 3C. Oh no, still 3D. Oh no, it's correct. Good. Oh, I'm sure in the hard copy version it says -1 to +1. Well, maybe I've reread it. Anyway, good. That's the same answer I got. Okay, now on Desmos, I thought I could show you what this looks like. Firstly, there's our function. I've typed it in here. If k equaled 0, right, you would be left with x on x squared. And you might have actually been able to think about this before you even started the question. Right? Just imagine, well, what if k equals 0? What would I be left with? I'd actually be left with 1 on x. I wonder if I can get my pen to work here. This only seems to work on this. Let's try. See if I can pen equals x on x squared. What does that equal? 1 on x. And you know what that looks like. It's a rectangular hyperbola. It's drawn for you there. Now, this function is always decreasing, right? So working from left to right, what's happening to this gradient? We're going downhill, 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 downhill. Yeah, okay. So that's always decreasing up here. I mean, there's a split, there's an asymptote, but then decreasing, 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 decreasing. So the hyperbola is a function that's always decreasing, which is interesting. I just need to trash that. All right. Now, if I go to positive, all right, I've gone to positive k, I've gone k equals 1. Yeah, okay, there's an increase now. Quite a different looking function. Let's gradually go back from 0. Whoa, it's kind of cool. Is this always decreasing? Well, that was, and that was. What about the middle? Yep, downhill, downhill, downhill. There's a point of inflection, but it's not stationary. So it doesn't go to gradient 0. It's always decreasing the whole way through. And if you just gradually went down, we're going to get to -1. Okay, still decreasing. And then I'm just going to tip over that point. Whee! Look at that business. Here, now we're increasing. So it's actually a really fine range of values from -1 to 0. Interesting question. Thank you.